This question is a thermodynamics free response question from 2008 AP Physics B exam. And the graph you see in the question is a pressure versus volume graph. And the question says a 0.0042 moles sample of a monatomic gas is taken through the cycle shown above. The temperature T1 of state 1 is 300 kelvins. A. Calculate T3 and T2. For the A part, we can simply use the ideal gas law PV equals nRT. Since nR is the same at all the points 1, 2, and 3, and it's equal to PV over T, we can say that PV over T is same at every point. So P1 V1 over T1 equals P2 times V2 over T2 equals P3 times V3 over T3. To find T2, we should look at the process between 1 and 2. The process from 1 to 2 is isochoric process because volume doesn't change. Since the volumes are the same at the points 1 and 2, we can simplify this equation into P1 over T1 equals Pt over T2. And when we substitute the values from the graph, 100 times 10 to the third Pascal over 300 kelvins equals 500 times 10 to the 3 Pascal over T2, and we get T2 equals 1500 kelvins. Point T3, we again look at the graph. If you look at the graph, we see that P1 equals P3, so we can simplify this equation into V1 over T1 equals V3 over T3, and 1.0 times 10 to the negative 4 meters cubed over 300 Kelvin is equal to 6.0 times 10 to the negative 4 meters cubed over T3. When we plug in the numbers, T3 is equal to 1800 kelvins. Part asks if the net work done on the gas in one complete cycle is positive, negative, or zero. We know that work total is equal to work done in the process from 1 to 2 plus work from 2 to 3 plus work from 3 to 1. And we know that work is equal to negative P delta V. Since the first process here is isochoric, delta V is 0, so work 1 from 2 is equal to 0. Now we need to find work from 2 to 3 and work from 3 to 1. Work from 2 to 3 is equal to negative P average times delta V. Since it's a triangle, we can use pressure average is equal to negative 500 plus 100 times 10 to the third over 2 Pascal times V3 minus V2. When we plug V3 and V2, we get negative 150 joules. And for work 3 to 1, we again use P delta V. Here we use P 3 because P1 and P3 are the same. And this is equal to positive 50 joules when we plug in the numbers. So work total is actually negative 50 plus 50, negative 100 joules. So we mark the negative choice here. For the D part, so let's see. Question asks us to calculate the heat added to the gas during process 1 to 2. First law of thermodynamics is the law of conservation of energy for thermodynamic systems. And the equation is delta U equals Q plus work. Since work done during the process 1 to 2 is equal to 0, delta U is equal to Q. And we know that delta U is equal to 3 over 2 times nR delta T. We just simply plug in the numbers. 0 over 2, 0.0040 moles, 8.31 joules per mole Kelvin times 1500 minus 300 Kelvin, and we find Q as 60 joules.